Welcome back to part 2 of Module 13, Lesson 6, where we continue our study into similarities and transformations. We are now on example number 2, where we need to find out whether or not these two rectangles are going to indeed be similar or if they're not. First thing you would always do on something like this is to compare the corresponding sides. So right here they took and said side SP, that's this one right here, corresponds to side XY, which is right here. XY is 1, 2, 3, 4, 5, 6, 7. SP is 1, 2, 3, 4, 5. So that's going to give us a ratio of 5/7. 5/7. And that is going to be the same ratio that we would have for QR and ZW. So QR and ZW is also going to be a ratio of 5/7. And then we need to compare PO and YZ. That's going to be a 3 to 1, 2, 3, 4. So right here we're going to compare, and we've got a 3/4, which would also be the same ratio for the comparison between RS and WX. Need to make a fraction here. Going to be, oh, that's not right. Let's fix all that. And 3/4 there. Except, and what do you notice? I notice that all of those fractions are in simplest terms, and you have two different fractions there. Because you have two different fractions, these ratios are not going to be equivalent. When they were in simplest terms, they do not line up. The corresponding sides do not line up. You're done. At that point, you can say, nope, not similar, and quit. Easy math. Now you get to work extra example number 2, where you're going to be comparing rectangle ABCD to rectangle EFGH. We're going to take and find out whether or not the corresponding sides are congruent. If they are congruent, then you're going to have to figure out what kind of transformations are going to be needed to get them to overlap so that they will be similar figures. Okay, I've got it all set up now. I went and wrote up the ratios comparing my image to my pre-image. The image goes on top, the pre-image goes on the bottom. From here, side EF is 1, 2, 3, 4, 5, 6, 7. So that's going to be 7 across, which will also be 7 there. So EF is going to end up being 7, and I can also say that GH is going to end up being 7. And then from there, I'm going to compare that to AB, 1, 2, 3, 4, 5. So I can put a 5 here and a 5 there. So right now, the ratio I have for those two is going to be a 7:5 ratio. Next, we're going to take and continue going to comparing side FG, which is 3, to side BC, which is going to be 2. And that would be the same ratio here of 3:2. Aren't those all already in simplest terms? They are. In simplest terms, are they all the same? They're not. Boom, you're done. That's all there is to it. Because the corresponding sides do not have an equal ratio between them, we can stop right there. We can totally skip the transformations thing. It ain't needed. We're not going to do anything, because right there we can say not similar, done. Once you've proven they're not similar, you do not. Now let's work on identifying some transformations. Similar figures have the same shape but may have different sizes. The sizes of the two similar figures are related to the scale factor of the dilation. You can determine the sequence of the dilation followed by the congruence transformation that maps one figure onto another. And once again, all this stuff we've already covered. 0 and 1, you have a new figure that's smaller than the original. If it's equal to 1, the scale factor is equal to 1, they're the same size. Greater than 1, your new image is going to be larger than your pre-image. No great revelations here. We have beat that horse to death, okay? It's down. Leave the pony alone. Square ABCD is similar to square EFGH. So right there we know that they're similar. But I also noticed that they were rotated. If you take a look at the order that is given, A right here started in the top left. Wow, E right here, it started in the bottom right. So there was a rotation that took place to get the orders to line up that way. Now, from here, what are we going to do? First thing we need to do is find the square factor, or the scale factor of our dilation. All of these are going to be the same because they're all squares. Remember, you do the new item over the original item, so you have a 1:4 ratio on all of them. So I'm going to plug it in here as a 1/4. I wonder if I can highlight, copy, and paste. Let's find out. A 1/4 here, a 1/4 here, a 1/4 here, and a 1/4 here. Accept and check. All those are the same. We have started off by finding our scale factor of the dilation. Next, we need to take and apply that. We're going to go ahead and do that dilation as the first thing. I'm going to do a dilation by a scale factor of 1/4, which is also known as 0.25 in the computer. So right now, hold on just a second, boys and girls. Oh, there it is. Yep, right now we're looking at this one right here, this green one. It gets confusing sometimes. That is going to be the dilation of this original one that was right here. That's going to be my start. Now that I've got my dilation done, the next thing I'm going to do is a rotation. If you look, these things are rotated around. Remember I talked about how the top right was my A and my top left was my A and my bottom right was my E? That was my clue that a rotation took place. So I'm going to add my next transformation as being a rotation. I'm going to do it. It doesn't matter if we end up doing it clockwise or counterclockwise, because it's going to be 180 degrees either way. But I'm going to start at 170 degrees. And now you can see the orange square right there. I'm going to keep going and keep going and keep going all the way up until, boom, 180 degrees. And now the two of them overlap completely. Scrolling down here, so the transformations that map square ABC onto square EFGH consist of, we start off with a dilation with the center of the origin and a scale factor of 1/4, or the 0.25, followed by a 180 degrees clockwise rotation around the origin, check, and it checks. The figures are similar, but we didn't even need to do math to know that, because they're squares. All squares are going to be similar figures. Now it's your turn. Pause the video, look at extra example number 3, find out if they're going to be similar, find the scale factor, and then find out what you need to do to the map to get them to match up. Go. Okay, so first thing I need to do is I'm going to set up my ratios. I'm going to be comparing my new figure to my old figure. So my new figure, let's go ahead and just start off with these side lengths for, these side lengths for here. So that means I'm going to have HO corresponds to point HG right there. Okay. Next, I'm going to say that OM corresponds to FG, and then I'm going to take from there and say that NM is going to correspond to FE. I'm going to compare those. I'm not worried about that slant height. If those three are good, everything's going to be good. So the first one, I've got 1, 2, 3, 4, 5, 6. So I can say that that is a 6:3 ratio. That simplifies to be 2. Next, I've got 1, 2, 3, 4 compared to 2. A 4:2 ratio, also 2. And the next one is going to be a 4:2 again, also simplifies to be 2. So all three of those have the same scale factor of 2. That's going to be my first step in working this. I'm going to jump back over to the textbook, which is, totally lost it here. There it is. For the textbook here, I'm going to let everything load. And then I'm going to start off with a dilation, which has a scale factor of 2. And now you can see this one's as big as the one beneath it. After a dilation, I'm going to add a reflection across the x-axis, and boom, it's done. That's it. You can see them overlapping down here. We have covered it up. It's done. So which sequence of events did you use? We used a dilation with a scale factor of 2, followed by a reflection across the x-axis. That's what you would write in this box right here. Super easy stuff. Moving forward, Ken enlarges a photo by a scale factor of 2 for his web page. He enlarges the web page photo by a scale factor of 1.5 to print. The original photo is going to be 2 inches by 3 inches. So let's think about this. We start with the original photo. From there, we enlarge it by a scale factor of 2 for the web page. So I'm going to take and highlight that. And then we take that and we enlarge it by another scale factor of 1.5 to print. And we know that the original, let's go ahead and highlight right here, the original is going to be a 2 to 3 inches. So we have got 2 different dilations that are taking place right here. Let's keep moving through this. We need to start off by finding the dimensions. First off, the dilation of times 2. When we 3 times 2 or 2 times 2 is going to end up being 4. 3 times 2 is going to be 6. That was when you put the photo on the web page, but he wasn't done. Then he made it larger, going from the web page to the what he printed, multiplying that by 1.5. That's going to give me a 6 right there, and this one is going to give me a 9 right here. Check that. Those are good. So the photo that he's going to print is going to end up being 6 by 9 inches. What else do they want us to do with this? Now, we'll determine similarity. Each enlargement is going to be the result of a dilation. Check the answer. That's checked. If the 3 photos were placed next to each other and then dilated following the transition maps, followed by transition maps, the photos onto each other, all 3 photos are therefore going to be similar. You can take and dilate them and then transition them on top of each other. Boom, they cover up perfectly. Those are going to be similar photos. We're going to reset this one, and we are now going to do the last extra example for this lesson. Extra example number 4. Go ahead and pause the video and work on this one. A t-shirt iron-on measures 2 inches by 1 inch, as shown. It's enlarged by a scale factor of 3. Let's start taking and marking stuff down here. Sorry, spam phone call there. Going to work on highlighting stuff up here. And the first thing I'm going to do is indicate that the starting one measures 1 inch by 2 inch. From there, what do we know? We know we're going to enlarge it by a scale factor of 3 to go on the back of the t-shirt. And then we also are going to have a second enlargement by a scale factor of 2 to be placed on the front of the t-shirt. Now we have all the information we need. We're going to start off with the way I would show my work on this is I'm starting off with a 2 over 1, or let's do it the way they did it. So we have a 2 by 1 thing, and the first enlargement is going to be to multiply by a scale factor of 3. So I have 2 times 3 and 1 times 3, which means those dimensions are going to be a 6 by 3 ratio. So now I have a 6 by 3 that's going to go on the back of the t-shirt. That 6 by 3, I'm going to do a scale factor of 2, or make that red. So I'm going to do 6 times 2 and 3 times 2. That's going to end up giving me a 12 and a 6. So the scale factor of the size of the image to go on the front is going to be a 12 by 6 image. Let's see if I can make that 6 better. There we go. We're going to jump back over to our textbook, and we say the dimensions of the largest iron-on to be placed on the front, we said is going to be a 12 by 6. Check that. That part checks. Both enlargement iron-ons are going to be similar to the original. Check that. And we're done with this lesson. One lesson to go, boys and girls. We're this close. This close.